When we talk about the world around us and how things move and interact, we often encounter various different natural forces. What are these forces in the grand scheme of things? These forces are fundamental reaction forces generated by the push or pull on objects in motion. There are four known fundamental forces in physics that govern how these forces and everything else in the universe behaves: gravity, electromagnetism, the weak nuclear force, and the strong nuclear force. Newtonian motion, aerodynamics, and buoyancy forces, for example, are composite forces derived from gravitational and electromagnetic reactions between objects. Imagine you're playing catch with a friend. Have you ever wondered why the ball you throw flies through the air, or why it eventually falls to the ground? Well, Newton's laws of motion help us understand these everyday occurrences. Sir Isaac Newton was a famous scientist who explained how objects move and also how gravity works on a practical scale. Newton's first law says that an object will stay still or keep moving at the same speed and direction unless a force acts on it. This means that if you roll a ball on a smooth surface, it will keep rolling forever if nothing stops it. It's like when you're on a swing, you keep swinging back and forth until someone pushes you to stop. Newton's second law, force equals mass times acceleration, tells us that the force needed to accelerate an object depends on its mass and how fast you want it to go. It's like when you push a shopping cart. The heavier the cart is and the faster you want to go, the harder you need to push and the more force you need to apply. Finally, Newton's third law states that for every action, there is an equal and opposite reaction. This means that when you push against something, like when you jump off a diving board, that something pushes back on you with the same force. It's why rockets can launch into space. They push out gases, which push back on the rocket, pushing it up into the sky. It is also why when you touch something, you cannot go through it because electromagnetic forces in the subatomic world from electrons from either side repel each other. This law also applies to objects being supported by a material structure above the ground. Newtonian gravity is still used and accepted as mathematical theory in many everyday contexts. Interestingly, electromagnetism also plays a role with gravity within general relativity. As it turns out, light and other forms of electromagnetic radiation travel along paths dictated by the curvature of spacetime. This means that electromagnetic waves, such as light, can be influenced by gravity. For example, light traveling near a massive object like a black hole will follow a curved path due to the warped spacetime around the black hole. Aerodynamics deals with how objects move through the air. When you think of aerodynamics, you might picture airplanes slicing through the sky or cars speeding down the highway. Aerodynamics relies on principles tied to forces like drag, lift, and thrust. Drag is a force that slows things down as they move through the air, while lift is the force that allows airplanes to fly. These forces are all related to the fundamental forces of physics. Gravity plays a role in how objects interact with the air, while electromagnetism factors into the way air molecules push and pull on objects in motion. Buoyancy is the force that causes objects to float or sink in a fluid, like water. This force is tied to the fundamental force of gravity. Gravity pulls everything towards the Earth, so when an object is submerged in water, gravity pulls it down. Buoyancy, however, creates an upward force that opposes gravity, allowing objects to float. This force is also influenced by the density of the object and the fluid it's placed in as molecules interact with each other. Now, electromagnetism comes into play with buoyancy forces through something called surface tension. Picture water molecules sticking together at the surface of the water, creating a kind of skin. This is due to the electromagnetic forces between the water molecules. Surface tension helps objects like the boat float on water by supporting their weight. In conclusion, forces like motion, aerodynamics, and buoyancy are all interconnected with the four fundamental forces of physics. It only takes us some time and careful introspection to see just how and why objects behave the way they do in the natural world around us.